everything we've named so far has been an alkane. We've seen all single bonds. Let's see if we can expand our repertoire a little bit and do some alkenes. So let's see, look at this first carbon chain right here. And here I drew out all of the hydrogens just to remind you that everything we were doing before with just the lines, it really was representing something like this. And when you start having the double bonds, and we'll explain it in more detail later on, it actually starts to matter a little bit more to draw the constituents because there's actually different ways that you can arrange it. Because these double bonds are, you can imagine, they're more rigid. You can't rotate around them as much. But don't think about that too much right now. Let's just try to name these things. So like we always do, let's try to find the longest chain of carbons. And there's only one chain of carbons here. There's 1, 2, 3, 4, 5, 6, 7 carbons in that chain. So we're going to be dealing with hept. We're going to be dealing with hept. That is 7 carbons. 7 carbons. But it's not going to be an heptane. Heptane would mean that we have all single bonds. Here we have a double bond. So this is going to be an alkene. So this tells us right here that we're dealing with an alkene, not an alkane. If you have a double bond, it's an alkene. Triple bond, alkyne. We'll talk about that in future videos. So this is hept, and we'll put an ene here. We'll put a ene here, but we haven't specified where the double bond is, and we haven't numbered our carbons. So when you see an alkene like this, you start numbering closest to the double bond, just like as if it was a alkyl group, as if it was a side chain of carbons. So this side is closest to the double bond. So let's start numbering there. 1, 2, 3, 4, 5, 6, 7. The double bond is between 2 and 3. And to specify its location, you start at the lowest of these numbers. So this double bond is at 2. So this is actually hept dash 2 ene. So this tells us that we have a 7-carbon chain that has a double bond starting. The ene tells us a double bond. Let me write that down. So this double bond right there, that's what the ene tells us. Double bond between 2 carbons. It's an alkene. And the double bond starts, if you start at this point, the double bond starts at number 2 carbon, and then it will go to the number 3 carbon. Now, you might be asking, well, what if I had more than one double bond here? So let me draw a quick example of that. So let's say I have something like, see, 1, 2, 3, 4, 5, 6, 7. So this is the same molecule again. 1, 2, 3, 4, 5, 6, 7. The way we drew it up here, it would look something like this. What if I had another double bond? What if we had another double bond sitting right here? How would we specify this? Well, once again, we have 7 carbons. 1, 2, 3, 4, 5, 6, 7. So we're still going to have a hept here. And it's still going to be an alkene. So we put our ene here. But we start numbering it once again closest to the closest double bond. So 1, 2, 3, 4, 5, 6, 7. But now we have a double bond starting at 2 to 3. So it'd be hept 2. And we also have another double bond starting from 4 and going to 5. So hept 2, comma 4 ene. That's what this molecule right there is. Now, sometimes this is the, I guess, proper naming, but just so you're familiar with it if you ever see it, sometimes someone would write hept2ene. They'll write that as 2-heptene. And probably because it's easier to say. 2-heptene. And from this, you would be able to draw this thing over here. So it's giving you the same amount of information. And similarly, over here, they might say 2,4-heptene. But this is the specific, this is the correct way to write it. It lets you know that the 2 and the 4 apply to the ene, which you know applies to double bonds. Let's do a couple more. So over here, I have a double bond, and I also have some side chains. So let's see if we can figure out how to deal with all of these things. So first of all, what is our longest chain of carbons? So we have 1, 2, 3, 4, 5, 6. And we could go in either direction. It doesn't matter. 7 carbons or 7 carbons. And let's start numbering closest to the double bond. The double bond actually will take precedence over any other groups that are attached to it. So let's take precedence, well, over any other groups in this case. There will be other groups that will take precedence in the future. But the double bond takes precedence over this side chain, this methyl group. So but it doesn't matter in this case. We'd want to start numbering at this end. So it's 1, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon. So we're dealing with a hept again. So we're dealing with a hept. And we have a double bond starting from the second carbon to the third carbon. So this thing right here, this double bond from the second carbon to the third carbon. So it's hept 2 comma 3 ene. Sorry, not 2 comma 3, 2 ene. You don't write both endpoints. 3, if there was a 3, then that would have been another double bond there. It's hept dash 2 dash ene. And then we have this methyl group here, which is also sitting on the second carbon. So this methyl group right there. So on the second carbon, so we would say 2 methyl hept 2-ene. So it's a hept 2-ene. That's all of this part over here, double bond starting on the 2 if we're numbering from the right. And then the methyl group is also attached to that second carbon. Let's do one more of these. So we have a cycle here. And once again, the root is going to be the largest chain or the largest ring here. And our main ring is the largest one. And we have 1, 2, 3, 4, 5, 6 carbons. So we are dealing with hex as our root for kind of the core of our structure. And it's in a cycle, so it's going to be cyclohex. So let me write that. So it's going to be cyclohex, but it has a double bond in it. So it's cyclohexene. Cyclohexene. Let me do this in a different color. So we have this double bond here, and that's why we know it is an ene. Now, you're probably saying, hey, Sal, how come we didn't have to number where the ene is? So if you only have one double bond in a ring, it's assumed that one endpoint of the double bond is your one carbon. So this, when you write just cyclohexene, you know, so if, cyclohexene would look just like this. Would look just like this. It could just like that. You don't have to specify where it is. It's just one of these are going to be the double bond. Now, when you have other constituents on it, by definition, or I guess the proper naming mechanism, is one of the endpoints of the double bond will be the one carbon. And if any of those endpoints have something else on it, that will definitely be the one carbon. So this is one of these both are kind of the candidates for the one carbon. But this point right here also has this methyl group. So we will start numbering there. 1. And then you want to number in the direction of the other side of the double bond. 1, 2, 3, 4, 5, 6. So we have 3 methyl groups, 1 on 1. So these are let me circle the methyl group. So that's a methyl group right there. That's a methyl group right there. That's just one carbon, right? So we have 3 methyl groups. So this is going to be, it's at the 1, the 4, and the 6. So it is 1, comma 4, comma 6. We have 3 methyl groups, so it's trimethyl cyclohexene. 1,4,6 trimethyl cyclohexene. That's what that is. Hopefully you found that useful.